Welcome to Maths Video Tutorials and welcome to this tutorial. In this tutorial we'll be looking at this exercise. We have got in front of us a circle. It has a chord AB. The angle at the center is 2 pi over 3 in radians. In part A we'll be asked to find the exact length of the major arc. The major arc is this one here, and this major arc subtends this angle here, so we need to find it. Let's do that. Now we know the full turn or a full circle is 2 pi radians, and we need to subtract 2 pi over 3 from it, and that will give us 4 pi over 3 radians. So the major angle is 4 pi over 3. The formula for the arc length is r theta. So that's going to be r is 15 times the major angle, 4 pi over 3, and that gives us 20 pi. We need to give it as exact. That's what it says here, exact length. So we need to keep it in terms of pi. And the unit, of course, is centimeters. So that's part A completed. Let's do part B. Now for part B, we've been asked to calculate the perimeter of the minor segment. This one here, shaded segment. Now to calculate the perimeter of this segment, we need the arc length plus the chord A to B. Let's first do the arc length. So we do the arc is r theta, of course. The radius does not change, 15. Now we use the minor angle, 2 pi over 3. That's 15 divided by 3. 5 times 2, 10 pi. We need to work out the chord A to B. So chord AB. In order for us to calculate the chord AB, we need to use the SINE rule in a triangle. So this is the triangle ABC. So that's my A, this is my corner B, and this is C. Our angle here at the center is 2 pi over 3. Let's write it down here. Now we know this is 15 centimeters and this is also 15. So this triangle is an isosceles triangle. So we can calculate this two angle here. So let's calculate the missing angle at the base. So we know the angles in a triangle add up to pi radian. So we need to subtract this angle here at the center, 2 pi over 3. That will give us pi over 3. So we need to divide it by 2. And that will give us pi over 6. So basically this is pi over 6. And this angle is also pi over 6. Alright, so that's sorted. Let's use the SINE rule now. So we're going to say the chord AB divided by the sine of the opposite angle to it, which is 2 pi over 3, is equal, I'm going to do 15 over sine pi over 6. And making AB the subject will give us 15 over sine pi over 6 times by this one here, sine 2 pi over 3. Now you can plug all these calculation into the calculator, making sure your calculator is set to radian. You will get the exact value. So the calculator will give you the exact value. And that's what we need, 15 root 3. So the arc, the perimeter I should say, it's going to be the arc plus the chord. And that is, the arc is 10 pi plus the chord, which is 15 root of 3. We make 5 the common factor, 5, it's going to be 2 pi plus 3 root 3. And so therefore the value of k is equal to 5. Okay, so that's part B completed. Let's do part C now. Now for part C, they want us to give the area of the segment as a percentage of the total area. So this is the formula. The percentage area is you divide the area of the segment by the total area of the circle and you times by 100 to get the answer as a percentage. First, we need to calculate the area of the segment, this one here. So therefore, we need to work out the area of the sector. So let's write it down as this sector is half r squared. R is the radius 15, so 15 squared times theta is 2 pi over 3. Now we're going to keep everything in pi. So if you plug this in a calculator, you will get 75 pi. And let's do the area of the triangle, this one here, ABC. We use that formula, the sine formula for the triangle. So we're going to say triangle, again, is going to be half, 15 squared, and times the sine of the angle, 2 pi over 3. So let's plug this in the calculator and we get, so that's why I get 97.4278, so on and so forth. Let's subtract the 2. So we're going to do segment, basically is the sector minus the triangle. 75 pi, subtract 97.4278. I can do the calculation right now, but I'm going to leave it till later. I'm going to just calculate the area of the circle, the full circle that is. This one here, the denominator. So let's do that. Area of circle. And that is, of course, pi r squared. Well, it's 15 squared times pi. So that's 225 pi. So basically we got the numerator, that's the area of the segment, this one here. We're going to divide it by this and multiply by 100. We're going to plug all this in the calculator. So let's write it down. Percentage area. So that is the area of the segment, which is this one here. 75 pi, subtract 97.4278, and we divide by pi r squared, which is 225 pi. So we plug this in a calculator and we will get 19.5501, 19.5501, so on and so forth. And we need to round it to 1 decimal place. Here it is, 1 decimal place. So we round it to 19.6. And there is no unit, of course. All right, so that's how we answer this exercise. I hope it was interesting and it was helpful as well. Thank you for watching and take care.